Thank you, thank you. So this is a project I've been working on for a couple of years, and I haven't reached version 1 yet, because I don't consider it finished. But it's a very good work in progress, and it's very useful. I use it myself. That's what I wrote it. I wrote it for my own needs, like my own dream cross assembler. This is the one, or the closest thing I got to so far. Version 0.7 was pushed this morning from downstairs. You know, I've been for some months. I refactored, I added a few architectures there. 65.8.16. We're going to go over that a bit today. 6809, which was used in SuperPet. If I also is used in the Vectrex I have downstairs on the table. Sorry. Oh, Coco computers. Yeah. Coco and Dragon computers from the British Dragon. 65.8.16 was used in Super CPU. Remind me. Sorry? Super Nintendo, of course. Yeah, so I'm gonna include some Super Nintendo examples in the future. I'm not there yet. This is so fresh, I have very few examples. But that's the backstory there. A bit about me. So the IKEA accent is Swedish. Yeah, I've been here 20 years, but it doesn't go away. So that there you know about my World Commodore history. So yeah, I started learn programming through the Commodore 64, so that's my passion. So of course 6502 was the first thing I covered in this assembly. And I've been part of those. I was a founder of Paragon, was a member of Triad for a bit, and then I was a founder of Sensor Design, meaning first members from day one. And now I'm still a programmer, thanks to the Commodore 64. So yeah, nowadays, of course, I work in C++, and there's going to be quite a bit of C++ here today. Not so much, but there's also going to be, I'm sorry for anyone with bad eyesight, it's hard to show code on the screen like this. I tried to make everything big and contrast good. Let's go to GitHub, actually. So here it is. You had the URL first. There's like a decent README. I go over all the basic stuff. Installation for Windows. I actually recorded a video how to install it on Windows, but I don't think you're going to see anything on the screen, so I'm not going to run it. But basically, you click this link, and then you grab the latest version right there from this morning. You unzip it. You don't need to install anything, and then you run c2_cmd.bat command file, and it will open a prompt, and all the paths are set. All dependencies are included. If you don't like it, just delete the entire folder and you're uninstalled. So very simple, but in the future it might be an installer. For Linux, of course, we can do it a bit easier, but not easier necessarily, but you go up and you clone it. Just copy. You see my mouse pointer? Go there. Okay, good. Clone. Go over to the command line. I can go there. I'll make this full screen. You guys can see anything? Make it a bit bigger if I can. All right. Git, clone, put the URL. This works on Mac OS X exactly the same way too. So Windows, Linux, Mac, easy. Even ARM Linux. I've tried it on not the last year, so it might be some issue. Yeah. Issue with WD systems? No, absolutely not. So what did I get here? I got the C2 folder. So I just cd in, and you can just do make. I'm going to do the -J because it's way faster. You do parallel building, and you're built. That's it. Now you would want to set up a path, maybe, or otherwise you have to explicitly give the path to the C2 executable. And let's show it. It is in the folder here. There it is. Linux build. From there, you can go, I'm going to actually leave this folder because I already have it installed, so I don't need to run it double. But you do C2 -- help or -h work as well. You get this useful help file. I have to mention also in memory of Brian Pope, one of our TPUG members, so he's no longer with us. The important thing with C2 Cross Assembler is the kind of template you're using. When you want to create the project, because there's supporting so many different architectures, there's going to be more architectures, you have to select the template you want to work with. So I'm going to create, first we're going to see what templates are available right now. So the first one you can disregard, that's my own personal template. But you can extend, you can actually add, I'm not going to go over that here, but you can extend the assembler with your own library folder, which it will find, and you can have extra configuration there and add to it without modifying the installed folder, so to say. Of course, you got 6502, C64, and then a convenience one, C64 with Vice emulator pre-configured. I'm going to be using that quite a bit. Atari 2600, NES ROM, TG16. Yeah, you see the list. And the new down there is 65816. That's like new for a couple of days ago. And of course I had to add the Super CPU because that's Commodore related for this event. And the final one is the Void template. It's actually an assembly template without any architecture. It's more if you want to hack the assembler for the hacking itself, but it can also be useful to build tools. I think last time I presented this, I'm not sure if I showed. If I have time, I will show you what you can do with the Void template. But I think we're going to start. We create a Hello World 64, and then we do C2, create project, C64 Vice. We name our project. Oh, did I have a hello here? I'm going to call it test, just in case. So I don't. Now you can optionally create the folder where you put it to, and I'm going to put it in test. So test in test folder. And this should actually now just work. First run, it takes a little longer. Oops, I'm full screen. What happened to the... I'm going to go into the test folder. I'm going to run it again here. Okay, there we go. There's the emulator popping up. Oops. Hello world. And we can go and have a look at the... I'm going to quickly browse through these. You prepare everything, but then you lose the file you wanted to show first. So I will just go and get it. Test. Make this bigger. So this is what you get when you create the project. You get a Hello World first thing. So you might notice that it's like C++ includes, very alike. And they actually are. This is a C++ environment you're in. But you can write assembly in it. And whatever the assembler doesn't recognize, it will pass forward to the C++ compiler. So you can use C++ for meta programming. So if you want to generate code, you can just write a for loop. Or we're going to show some examples about that a little bit later. But this is easy Hello World. I could point out, like Dan was wondering, what am I doing here? These colors. The BEQ plus, the ones you who know labels or know some assembly, you might wonder, what is this? It is just an optional shortcut. Plus means jump to the next label declared. The same does with minus. Jump to the previous label declared. And here you see actually just a little colon out there. And that's called, in this assembler, it's called an anonymous label. So you don't have to name your labels, you can just refer to them by count. But you can just as well name this as loop, for instance, and they would work perfectly fine. And if you don't want to jump to minus, you can jump to loop here. Yes?
Is it like a local namespace or like a global namespace? Like you could like put like a nothing next to a colon. Like, you know, like a single character next to a colon, and still like like multiple of those in the program.
You can have local labels, if that's the question.
Oh, okay.
Yeah. So for instance, if I call this main here, main colon, we could call this dot loop, and then you can just jump to dot loop. And you can also, I mean, if you want to reach a local label, you can do main dot loop, and you can branch into the other namespace.
That's very useful.
Yeah. So this is not the first assembler asset. There are a couple of assets, and I think actually another popular assembler, kick assembler. I say another popular because mine is not popular yet. Kick assembler got some really good namespace structure as well, but not with the dots. But you have use C++ scopes. I might add something similar too, to have it even more scope isolation at some point. But so far for programming Commodores or retro computers, projects are not that big, usually. So actually this is just a Linux Kate editor. Yeah, it's a bit all around. Some of the color codings might be wrong because it doesn't recognize assembly. I think it's interpret this as some other type of assembly or C or something. Question? Yeah.
Hi. You were saying if it doesn't recognize, it's going to treat it as C.
Yeah.
C++.
Yeah.
What happens to that?
So that is yeah. No, it doesn't.
Okay.
It's C++ for meta programming, meaning I can do a quick example here. I could write something like.
Maybe referring to something in an include?
Well, you can too. That's a different question. But you can do a for loop here, for instance, for int a equals 0 less than, oh, sorry, a less than 10, a plus plus. And just to not cause any harm, let's just do nop here. That will put in 10 nops. It will render 10 nops for you. So that's how I mean with meta program. It's kind of macro. Only assembly instructions will actually generate final code in the end. But there's a lot of C++ feature you can use. You can use the structures if you want to render your own data. If you want to create a sine curve table, just write it in C or C++ straight there, and put the label in front of it, and you can access it from assembly code. So this is like it was called assembly scripting. I just didn't want assembly to be scripting to be an add-on. I wanted to be fundamental, so that's why I took a C++ compiler, and then I added assembly on top, rather than the other way around. So that is the approach I kind of took with this assembler. It also, I mean, it has some few downsides, and that's if you get an error, it might look cryptic. I am doing all the preprocessor parsing, so at least the compiler knows what assembly file and what source line the error is. But if it prints something, it says, this doesn't make sense. It's going to be in kind of C++. Sorry, the in between?
Can you see kind of the in between, like after it's processed?
Yes, you can.
So you can see the thing with the 10 going on.
You can see this. This is basically rendered into an intermediate C++ file, and that is then compiled, and then that is run, and that renders your binary in the end.
You can't see that.
We can open that file. I was going to leave that to maybe last thing advanced.
Sorry.
yeah. But the curiosity is correct. Yeah. No problem. Yeah. Yeah.
Hope this has been jumping ahead either, but so you just have the no op without like a semicolon or anything. Does the
No semicolon needed there.
how does the interop between them know that that's like a single expression that should be?
Well, yeah, because I had to make the parser to understand enough C++ to when it finds something I'm not sure what this is, it starts to look through. We're going to get to that the macros, and if it finds that a macro, then oh, this is most likely assembly, and it's going to do its thing with it. Otherwise, it just leaves it as is for the compiler.
But how does the for loop know to stop after?
Oh, so this maybe if I can make it a bit clearer. But in C++ or C, it's legal to do without a block.
Right.
But normally you can put the block.
Yeah. But in the case where you don't have parentheses or the braces, does the C++ compiler know enough about what you did to know that an expression was read?
It's going to see it as not turns into one single C++ expression. And if I want to have more instructions, I would have to put
So does that reach the C++ compiler? Or
the not. Not in that form. It has been converted.
so what does the C++ compiler see? Oh, okay.
That is it's converted. So we'll get to that to the end if we have time. Otherwise, just come by my table and I can show everything later. All right. So we got that part. Let's switch over to close this. Now I'm in. I'm gonna do this bigger. Hope you guys can see some. Oh, there we go. So if I do help now in a project, you're gonna see that there are a few the Commodore 64 specific parameters have been added to the help. So you have the out program file. So that's a very CBM specific, shared by the PETs and the VICs and Commodore 64. You can also have it sharp-hacked or run length encoded compressed. And there's also support for the Vice emulator, so you can send in symbols and breakpoints even. So that's kind of extended. If you create another C2 project, let's say for Vectrex, those options won't be there. So it depends on, it looks, if it's in a project folder, see what kind of project is this. It tries to load the project and then offer extra parameters. One thing that could be useful sometimes is to see, you just build by entering C2 and it will build. Actually, it probably launched the emulator again. Yes, there it did. We can close that again. You can also do for rebuild if you want, and you can also do verbose mode. Then you see a little bit more what it's doing, and you see the hashes. Well, now it started the emulator on another screen, but it's using multiple paths, and it's using the hash to determine when it's done. So each pass, it renders a binary, but it might not have resolved all the references yet. So it will try it again, and you see the hash has changed from pass 1 to pass 2. At pass 3, it got it right, but it doesn't know it yet until it does pass 4, and then you know, okay, everything is resolved, all forward references. And forward references is not something most old assemblers don't do. And you can see that if you have an instruction or the 8-bit branching and 16-bit branching, and you want to have a smart assembler that takes the correct, 8-bit preferably, 16-bit if it can't reach it. But if the branch is forward to something it doesn't know yet, old assemblers tend to just default to 16-bit, always, even if you're just jumping a couple of bytes forward. And so that's forward referencing, and that's very important when it comes to expanding macros, intelligent macros, and things later. So that's visible with verbose, and you can actually add more. If I do yeah, you can up to 7. It's going to get very noisy, and you start to see the internal workings a little bit more. And you see the the C++ compiler, also what it's doing in the background.
What is this dirty mean?
Sorry?
Dirty.
Dirty means that the file has changed somehow, or that parameters. In this case, I did a rebuild. So then it flags it, okay, it's dirty. I need to rebuild everything from scratch. Otherwise, it will try to rebuild, of course, only the individual files you touched. That's it there. I'm gonna switch over here, and I think I had opened everything beforehand, and now I don't find it. Anyway, we'll go. So with each project created, you get a little project file. It looks like this. So it's in JSON format. It's the name of your project. Maybe I can change. Dan gave me some good input on the color theme that worked for GitHub Dark, still clear. So here you see the arguments that's sent to C2. So the project file, it's kind of convenient to put things in here, how you want to save your output. So here we have the out PRG, the very Commodore specific. So it has a minus and a plus, and you can actually put real addresses here. You can write. I would actually use 0801. If you want to save all the way up there, you can do, and it will write it into test PRG. So the minus and the plus that I replaced there means like the lowest address assembled to the highest address. So it's kind of a convenient thing. So that's what it does default, but you can specify any address you want, really. Then execute there. See, I put the x64SC, so that's the device emulator. If you don't have SC installed, just change it to x64. And then a bit less noise. And here I'm sending the symbols. All the labels in your project are sent into Vice and entered. So if you open the debugger, you will have your labels in the machine code monitor right there. And of course the last argument. So this is just Vice, the program to execute. You might notice that the source file test.s doesn't exist. It's test.cpp. It is also created alongside. I can go back to the folder test and do. Oh, that's a bit bigger. So there's the JSON file first, the CPP file, the PRG file that we generated, the assembly file, and then the symbol file. So those are intermediate files. And if you do look for hidden files, there's an IM folder there. And this is the advanced stuff we can look at later. Here are the intermediate. The test.ii.ii is actually translated. It is the final file compiled by C++. And it's created into the test.so file there. On Windows, that would be test.dll, same thing. That is then loaded and rendered. So anyway, I went a little bit more advanced than I was planning here, but now you know how that kind of works. So if you don't want to use a project file like this, there's direct assembly as well. And the syntax would be D for direct, and then you say your template, and maybe use mygame.asm. And it would just build it like any command line assembler. But it does have the built-in project file with the automatic emulator. But you know, if you do makefile and you script yourself, this is probably the approach you would pick. Sorry, run it.
For like compression on the binary, or like intermediate commands on the.
Yeah, I mean, you can either modify in the to run an extra, let's say, external cruncher or something. You can in that, go over here, in the execute section here, you can call your own script and do whatever you want, or you can actually call it here. You can actually stack, in this case I'm using Linux Bash, you could stack thing with semicolon. I'm not sure how well that works in Windows, but it's definitely doable. There is a built-in, say, char packer, which is fastly compressed. I will show that towards the end if we get there. But yeah, absolutely. I will go over to, let's go here. Control Shift, a bit bigger. LS, or I'll just do LL. So these are examples. So there's a couple of example folders that just you get from GitHub too. Of course, C64 got the most things. I added the C64 Super CPU now. So this is a good reference if you want to look how the syntax for certain things. Just go look in the examples. I'm going to enter C64, and I'm actually going to enter Plasma. So we've got a bit of a demo effect here. I can show what's in there. I ran it before, so it's already there, but we will just build it. Let's do this. So this is done by a friend, Johan Samuelsson, or Lavassa from Sensor Design. So he was one of the first users of this assembler. So it's just a simple demo effect. I thought we can have a little quick look at the code. It doesn't do a lot more than this. Close it. Where is the plasma? Everything moved around. Have a quick. That's the one. So recognize the includes from the hello world example. So he decides to define pi here. It's useful if you want to do some sinus curves. And you can declare variables like this. They're not very C++ at all. These are actually built-in variables to the assembler itself. But you could technically write int if you want. Then, though, it's C++, and you would have to add the semicolon. The assembler will still take care of this kind of syntax, which C++ wouldn't do. That would be legal.
Question.
Yeah.
Well, I verified that that's the correct version. That's the correct value of pi. I memorized it.
Oh, sorry. The 10. So that's a hexadecimal 16.
No.
Oh, the pi. Oh, yeah, of course. Yeah. I'm sure you know it by heart. Yes. Yeah.
Everyone knows pi is exactly 3.
Most people know 314, and then maybe 159, and then, yeah.
1416.
Yeah, you can round it. Yeah. So then he's declaring if you see also the comments are in C++ style. So semicolon does not work for comments. So that's kind of a downside with this assembler. Most traditional assemblers use semicolon for comments. Not here. A bit more variables, and then he starts to declare macros. So this is how you can declare a macro in this assembler. So he didn't, well, it's actually included, but he decided to do his own anyway. He wanted to fill bytes. So this is how he did it. How many bytes, first argument, and what value, second argument. And then he just did a for loop and byte, which is a, Then he didn't want to do LDA STA, so he did a move 8 macro. And here it's actually with the bracket, so it will be immediate value first, and then just store. So he did a few variants of that, and move 16 for 16 bits. Then he did a little shortcut here for IRQ. You know, the good house cleaning stuff you have to do before and after IRQs are done here. And then he actually does a long branch. So instead of B and E, you do a BQ over and do a jump. That's good to have. I'm sure there's a reason for it later on in the code. VSync is a just nice way to get to the V blank of the screen, wait there. So he has a macro for that. A few jumps. Here's the basic startup, which is a macro included with the C64. So you get the simplest sysline just to get started from basic. And then he put some data in Word format. So I didn't write this code, so I'm not an expert at commenting, but I figure it gives you a little idea of the syntax or his interpretation of how to use this. And here is the move 8 he declared above, which is basically just LDA immediate and store. Here comes the vsync, etc. But main loop, you see, has 2 for loops. Because plasma effects is a lot of just moving data and looking up through sine tables. So he is unrolling this code for the entire screen for the y coordinates and the x coordinates, and then this entire section in the middle of the loop is then repeated. It probably takes a lot of RAM. I didn't look how big this is. But. So this is repeated x times y times with the variables x and y. So hopefully that's fun. So you got an idea of macros there, what they are. And the thing with this assembler, everything is a macro. All the instructions for any architecture are built on macros. So if you have your own CPU or some rare CPU or made your own hack, whatever, and you need an assembler for it, this is a pretty good alternative because you can declare your own. Here's 6502. So here's add carry immediate first, the macro. And what it does, this is I would call it the atom call. This calls the C++. Push in a hexadecimal 69 for the opcode, and then push your provided intermediate value. And the entire instruction set is built like this. Here, there's an if here. This is because and certain commands, of course, you have the 0 page, and then you have absolute mode. And depending on if the address fits, if it's lower than 8 bits, you probably mean 0 page. Else, you have to go to 16-bit version. So it's all included here. But you can explicitly, I'm going to just modify straight in the code here, just as an example. If you do STA, 01, that's going to be 0 page for sure. Addressing mode. But if you do it this way, it is still, the value would fit in 8 bits, but you're explicitly setting it 16-bit. And this is detected here in this if statement. So you have all the choices. And that's why there's an if statement there. Yeah, so it's 6502, all of the instructions. If you're into unintended opcodes, meaning sometimes they call them the illegal opcodes, they are all included as well. So if you don't want to use them, just remove it or don't include it. But they are all here, every single one. And some of them are unstable, so it's not recommended to use them for everything. But some are more stable than others, and this, I don't provide any documentation how to use them, but there's a link up, and I think there for reference. There's an excellent PDF that goes all of them. All right, let's check out the super CPU. Go back, C64 as CPU. Should only have, oh yeah, let's do a hello world there. Right, I'm gonna run it, just enter C2. Off. Very simple. I will show you the code. So it's not, I didn't have a lot of days to prepare 65.8.16 examples, but at least there's some non-6502 here. There's 16-bit registers used to clear the screen, for instance, here LDX 999. That's not normal Commodore 64 stuff. I can start with first the basic startup. It starts in Commodore 64 compatible 6502 mode. Then I actually provide a macro here, which we can have a little look at if you want. This will switch the CPU over to the 16-bit mode. Not 16-bit, 65.8.16 mode, more instructions. And then this macro will switch at least the index registers over to 16-bit. And the last little macro, this is what 65.8.16 is tricky with. The programmer and the assembler need to know some of the state flags in the CPU of what to assemble, because the CPU changes behavior depending on a flag. So an opcode in 6502 mode can mean something a little bit different in 65.8.16 mode. So that problem is left to the programmer and the assembler to deal with. And this is what the X16 macro does there. It tells the assembler that from this point on until something else is said, the index registers are 16-bit. So you kind of have to specify it twice, once to set the CPU and one to tell the assembler this is my intention right now. And that's why this would work to clear the screen. Sorry, 5 minutes? Oh, we're running out of time. Okay. Yeah, okay. That's 65.8.16. We're going to jump quickly over to this is an open source VPONG for Vectrex. So this is now 6809 CPU. It's a little more complex, the instruction set. It's still familiar to most 8-bit people. This is, I've only converted, this is not the greatest example because it doesn't use all the width of addressing modes, but it does prove that its basic is working. I would, if you guys want to program stuff with this assembler, I'm happy to include your project as examples if it's open. I need more bug testers. I'm kind of confident it's most works, but I'm not sure about especially 6809. I do have also a colleague of mine created CLog 80. It's included. I haven't tested it myself. It's very untested, but it is in theory supported. And I thought I would have Motorola 68000 ready by now, but it's a beast. It's insane. Especially if you don't want to manually write all those macros. So I took a generating approach. I got to 90%, but it's not done yet. I think maybe we'll just round it off there. Do we have any more questions?
Do you have VS Code extension?
Sorry?
Do you do a VS Code extension?
Oh, meaning for VS Code for as an editor? For this?
Extension?
No, I don't, but that's actually something I could poke around with and include in the folder.
And then use a debugger VS Code to actually
Yeah.
debug this line by line.
What about using language other than Plus to,
Well, I was thinking, I mean, this could be done. Now it's built on top of C++ because that's my home language. But you could, in theory, do this on C# or Java or anything you like. It's just I didn't take that approach, but there's nothing preventing it. You just have to do a different parser to see what's different in that language to keep them separated. Yeah. Okay, we'll just go to the super advanced last thing. I'll just open it. Can go to, where are we? Hello. We can go into that intermediate folder. Oh, not that. Didn't I build this? No, it was test. So I'm going to go to the bottom because these are mostly C++ includes. They generate a lot of junk, and I'm going to have to make this big. So this is the C64 hello world, what it turned into in intermediate code. Okay, what do we have here? Okay, we have the macros first. So first, the macros are expanded. All the instructions we needed to use. Okay, which one is first? So this is the byte macro. If you write byte, it was expanded into this. Basic startup was expanded into this. So these are called lambdas in C++. So this is machine generated, not meant to be read, but just for if you're curious what's going on under the hood.
I was wondering about that. It's a line numbers are like 208,000.
Oh yeah, there's a lot of lines because all the C includes were on top. So I just have to forward to the bottom. There's a lot of, but that's how C++ kind of works for C. So it turns into this intermediate language, but in the end, it's just pushing bytes out to an output stream, and that is your final binary. You know, but it does it. It runs it several times, once for each pass. Okay, I'm gonna stop it there. I'm sorry it was technical and hopefully not too hard to read.
I was in the back end.
Okay, excellent. Thank you.